We're beginning a section or a unit on functions, and 4.3 relations is the first section in this unit. We're going to go straight to our Cornell notes and define what a relation is. So a relation is, this is pretty easy, just a set of ordered pairs. Just a set of ordered pairs. So points, a set of points. And there are three ways that you can show a set of ordered pairs, technically four ways that you can show a set of ordered pairs. You can list them either vertically or you can list them horizontally like this set here. You can make a table, you could graph a relation, or you can use a mapping, and the mapping is the only new one here. So when we do the mapping, we want to put the x values in order from smallest to largest, -2, 0, 1. And the y values would also be smallest to largest. And then you connect the points to the correct value. So the point 1, 2, 1, 2 starts from 1, and it should go to 2. Just realize this. Okay. -2 should go to 4, which it does, and 0 should go to -3. So I just got those mixed up there. Alright, so when you do a mapping, you draw an arrow from left to right. There's an arrowhead on the right side, and you should have arrows there. They're not just lines, they have arrows. And then your x values are in an oval on the left, your y values are in an oval on the right. You can get away without putting x and y up here for your mapping. So in example 1, it says it expressed the relation as a table, a mapping, and a graph. So this is easy. As a table, here are your x and your y. Now these go together. So 3, 2, -1, 4, 0, -3, -3, 4, and -2, -2. These do not go in order. You keep these pairs together and you can just leave them in the order that they're in. So don't try rearranging them. Just bring them down. That's your table. A mapping and a graph. So for your mapping, you need to put these x values in the oval on the left. And they need to go in order from smallest to largest. So -3, -2, -1, 0, and 3. On the right side, we want to do exactly the same thing for your y values. There's a slight difference here because if you look closely, there's a repeat in the 4. Now we don't put repeats in the mapping, so this one will have one fewer value here. So in order we go -3, -2, 2, and 4. So you only list that 4 once. Now we go back and just check each point. 3 goes to 2 with an arrow. -1 to 4 with an arrow. 0 to -3. -3 to 4. And -2 to -2. Alright? So in order from smallest to largest, in order from smallest to largest. And last, we need to make a graph, and we just plot each point. 3, 2, -2, -2. I'm sorry. Yep. -1, 1, 2, 3, 4. 0, -3. And -3, +4. So this is not a point right here. Alright, so a table, a mapping, and a graph. Pretty easy. Okay, the mapping is the only thing. You have to be careful that you put them in order. Okay. Next, we want to talk about what domain and range are. And again, you can go to your Cornell sheet. We'll identify domain and range. The domain is the set of all the x values in a relation. All right, and if we're writing the domain, it is similar to the mapping. There's no repeat. And usually we put them in order. Put them in order from smallest to largest. But it's not wrong if you don't put them in order. Okay? So the domain for this comes easiest from the mapping because we already put them in order here. So the domain is a set of values. So we use set notation. So you have your bracket. And you just write the x values, -3 with commas between them, -2, -1, 0, and 3. So this is your domain. These are your x values in order from smallest to largest. Your range, exactly the same thing, but the y values. So the set of all the y values in a relation. And again, no repeat. And we generally put them in order. Okay. So the range, go to the mapping, that's the easiest place. -3, -2, 2, and 4. Pretty easy. Okay. One more definition today. An inverse relation, or the inverse of a relation. Go back to your Cornell sheet. The inverse, you can get the inverse of a relation. It's obtained by switching the coordinates in each ordered pair. So for example, if you have an ordered pair that's 2, 3, the inverse of that ordered pair would be 3, 2. You're just flip-flopping them. Okay? So that is an inverse. So if we want to give the inverse of this relation, let's go ahead and write the inverse of this relation. You can just look at this list here and just flip-flop them. So the inverse would be 2, 3, 4, -1, 4, -3, -2, -2. That one will look the same, of course, because the x and the y are the same. Pretty easy, flip-flopping. So the mapping, we have to remember those stay in order. Domain and range in order with no repeat, same with the mapping. And then an inverse is just flipping the x and the y value in each point. So let's look at example 2. Express the relation shown in the mapping as a set of ordered pairs. Then write the inverse of the relation. So if we write it as a set of ordered pairs, or we call it the relation, you just figure out what point each of these represents. So the top arrow would be, in the order does not matter. 2 goes down here to 4. 3 also goes down to 4. 5 goes over to -7. And 6 goes up to -8. Now I just noticed something. These, oh, no, it's just fine. Just fine. So this is your relation. And then the inverse. Go ahead and write the inverse. Push pause here for a second. Write your inverse and see if you got it correct. All right, so your inverse should be 4, 2, 4, 3, -7, 5, and -8, 6. All right, so this is positive. Very easy. Just flip-flopping the x and the y values. No problem. Okay. Now, we're just going to go off on a tangent here and talk about these relationships in these graphs. And what I want you to do, I want you to actually look over these on your own, and I want you to come up with which graph you think best represents each of these scenarios. Okay, that's described here. And this one, 5, you have to write what's going on or describe what is happening. So this is the other way around. So you need to do 3, 4, and 5 on your own and bring those to class tomorrow with you.